Hey, so now that we're working in 3D, let's rethink all the transforms that we've learned previously. Now, first thing I'll talk about is when we say 3D, let's note that it's not actually 3 dimensions. And this becomes relevant now with some of our transforms. So note that 3D is actually 6 dimensions. Okay, we have 6 degrees of freedom. So spell them out. Of course, the one that everyone seems to know is position. That's our x, our y, and our z. So we have 3 degrees of freedom right there we can move around. Of course, in addition to our position, we also have orientation. Okay? So we can move them around 3 dimensions. We can also rotate around 3 different ways. So we can rotate around x, which is kind of like I need a better object. I use my phone. I rotate around x. When you rotate around an axis, imagine grabbing that axis and turning it. So if I rotate around x, here's my x-axis. I stick it in, and I rotate like this. So tilt forward and back. I can also rotate around y, stick it in, and rotate this way, right? This is turn left, turn right. I can also rotate around my z. And so this is my 6th degree of freedom here. And this is kind of like a spin. I can stick it through the phone and I can turn it this way, right? So I can spin clockwise, counterclockwise. Now, in other fields, there are standardized names for these. The tilting forward and back, like if you're into airplanes or engineering, it's often called pitch. Turning left and right is called yaw. Oops, undo that. And then the spin is called roll. So pitch, yaw, roll. Okay, just like that. So for the most part, our basic transformations, there should be no surprises. So in 3D, our translate just looks like this. Translate was a simple matrix where we leverage the structure to add a number to our coordinates. So one like this, x, y, and z. We make our identity matrix. And then in the fourth coordinate here, I translate x, translate y, translate z 1, like that. And this works. As I multiply it by, I get x plus, and then the w coordinate times a tx adds a tx to the x, just like in 2D, so no surprises. Scale, same thing. Scale x, 0, 0, 0, 0, scale y, 0, 0. We just multiply each component by our scale factor, and we can scale x, y, and z separately, like that. So there should be no surprises here. So we can transform, we can translate, we can scale, everything works as expected. However, rotation. This is where things get more complicated. Okay? Rotation gets complicated. It's not as simple as going, yeah, let's just do it in 3D. So the first thing to talk about is that our 2D rotation still works. Nothing changes. We just pad it with zeros, or the identity, I should say, right? So if I have a square like this, I can still do this rotation. All that we do now, if we think about being in 3D space, this is just rotation around the z-axis, okay? Like I talked about above. Rotate around the z-axis. And just by moving the parameters around about which, if it's applying to x or y or z, we can actually do the same thing for the other axis. We can do the same rotation also around the x and the y axis. Okay, and this will enable us to do these three things that we talked about before here, right? X, Y, and Z axis. And instead of going through this on my slide, I think it's just quicker if I just, on my tablet rather, bring up a slide. Here we go. So 3D rotation, and just like I said before, when you rotate around an axis, you envision you grab the axis and spin it. So rotation around the Z-axis, you turn the Z-axis and the world turns with it. Down here is the, I want my pointer, come on. Down at the bottom here, this is the matrix you're familiar with, right? We just padded it with the identity matrix. So this is a rotator on the Z-axis. But all that we have to do for the x-axis and the y-axis is move those parameters around a bit. So for the x-axis, we leave x at the identity, we change y and z. And for the y-axis, we leave the y at identity and we change the x and the z. That's it. So we can do rotation around the z, the x, and the y using the exact same technique that we've already learned. That was slide 17. Okay. So the last thing I'll mention about these guys is that, so these three rotations around the x and the y and z, they're known as our Euler angle rotations. Euler angle rotations. So you'll see this mentioned in a book or in a guide or an API. It'll say these are Euler angles rotations. You know exactly what they are. Sometimes it's just shortened to Euler rotations. So that's it. So for the most part, the transforms are the same, and the rotation's a bit more complicated, and the rotations, that's delayed, are a bit more complicated, but we can solve the basics at least and do our axis rotations just by shuffling that matrix around a bit. However, as I said, these rotations are more complicated, and in the next lecture, I'll get into the details of what the limits of these rotations are and what kinds of craziness we have to go through to fix it.